On the Tibetan Plateau in July 2012, researchers studying lightning caught something unexpected: a glowing orb, grapefruit-sized, drifting against the wind. By accident, they captured the first optical spectrum of natural ball lightning. This is still unexplained, the science that hasn't finished arguing. The orb vanished in under 2 seconds, but its spectrum revealed silicon, iron, and calcium, elements abundant in soil. This was no artifact, a ghost, finally caught. For centuries, ball lightning was dismissed as myth. Now, a lucky accident gave science its first concrete proof. The phenomenon was real, and its secret lay in the soil. But why did centuries of reports count for nothing? In 1638, an 8-foot ball of fire tore through a church in Devon, killing 4. Yet science called it a ghost story. Sailors, pilots, farmers, the reports never stopped. But each was just a story. No photograph, no instrument, no repeatable experiment. Eyewitness accounts, they said, are notoriously inaccurate. That lack of proof kept ball lightning on the fringes. As one researcher put it, with thousands of eyewitness reports, but few instrumental records and no consensus about a theory, ball lightning remains an unsolved problem in atmospheric physics. So it stayed a mystery until a routine study of cloud-to-ground lightning in July 2012. The instruments caught a glowing sphere drifting across the storm. They weren't looking for it, but they recorded its light. The video was remarkable, but the real prize was the spectrum, a fingerprint of the light. Every element burns with its own signature. So what would it reveal? Something known or something alien? The spectrum showed clear lines from silicon, iron, and calcium, elements abundant in soil. The orb was not pure electricity. It was made of vaporized earth. Published in Physical Review Letters in January 2014, the findings gave ball lightning a chemical fingerprint. It pointed not to the sky, but to the ground beneath our feet. So why did nobody stop it? Because the elements found, silicon, iron, calcium, are exactly what you'd find in the dirt under your feet. But how does soil become a glowing, floating orb? The answer, researchers proposed, is combustion. Lightning strikes the ground, vaporizes soil into a cloud of silicon, iron, and calcium. That vapor burns, releasing light and heat, a self-contained fireball. The spectrum supported a burning core of soil as the energy source. But what could make soil burn like that? One theory: lightning vaporizes soil. Silicon condenses into nanoparticles that burn. Another: microwaves trapped in a plasma bubble. A third: a network of nanoparticles, oxidizing and glowing. Which fits the evidence best? The spectrum's elements match the local soil, supporting a burning core. But other theories still have champions. In the lab, researchers have created glowing orbs that look remarkably similar, yet none have been definitively linked to the natural phenomenon. The mystery persists, but now with a solid lead. So the spectrum was a leap, but just one glimpse. Ball lightning remains rare, unpredictable, and largely unexplained. As one physicist noted, ball lightning is a rare and unexplained phenomenon, described as luminescent spherical objects that vary from pea-sized to several meters in diameter. But for centuries, ball lightning was a punchline. Scientists dismissed it as optical illusions or hallucinations. The lack of reproducible evidence made it easy to ignore. Yet the reports kept coming, from sailors to pilots, each one more detailed than the last. Eyewitness accounts number in the thousands, spanning centuries and continents. Each one describes a similar phenomenon. A glowing sphere, often hissing, sometimes passing through glass. But without instruments, these were just anecdotes. The 1638 Devon Church event was one such account. An 8-foot ball of fire entered the church, killing 4 and injuring 60. It melted metal and shattered windows, leaving witnesses in shock. Yet even this was dismissed as a tall tale. So science dismissed it. Without reproducible evidence, the phenomenon was relegated to folklore. It wasn't until the 20th century that serious research began. But even then, progress was slow. The lack of instrumental records was a major hurdle. But the 2012 observation was pure luck. The team was studying ordinary lightning, not ball lightning. Their spectrometers were pointed at the sky, ready to capture the spectrum of a strike. They caught the orb by chance. The elements matched the local soil composition. This was a crucial clue. It meant the ball lightning wasn't a mystery from the sky. It was born from the ground. The soil itself was the fuel. The spectrum confirmed a chemical reaction, not a purely electrical one. The energy source was a burning core of soil. This shifted the debate from electricity to chemistry, opening new avenues for research. But the spectrum did more than identify elements. It revealed the temperature of the orb. The lines were broadened, indicating a hot, dense core. That meant the ball lightning wasn't just glowing on the surface, it was burning from within, like a tiny furnace. So, what exactly happens when lightning strikes soil? The intense heat vaporizes the ground, creating a plume of silicon, iron, and calcium vapor. This vapor can ignite, burning like a flare. That's the mechanism the spectrum supports, a chemical reaction, not a plasma mystery. But lab-made orbs are often created with microwaves or electric discharges, not soil. They may look similar, but they lack the chemical signature of the 2012 event. So, while they help us visualize the phenomenon, they don't prove the mechanism. The real thing remains elusive. Yet, even with this evidence, skepticism lingers. Some argue the spectrum could be from a different source, like a lightning-induced spark. But the researchers checked. The spectrum matched soil elements, not typical lightning. That's hard to explain away. Researchers are now using high-speed cameras and spectrometers to catch ball lightning again. They're setting up networks to monitor storms, hoping to get more data. Each capture could refine the theory, bringing us closer to a full explanation. Yet the accidental capture proved something profound. Ball lightning is real, a physical phenomenon we can study, and it reminds us that science still holds mysteries. The next breakthrough could come from anywhere, even a routine thunderstorm study. The universe keeps refusing clean answers. Subscribe and meet the next one. Nothing about sperm whales is normal.